For this next example, we're going to take a look at a quadratic equation where the a value is something other than 1, and we're going to complete the square. So again, remember, I want to get that into an ax squared plus bx equals the constant form. Okay, I want to move the constant to the left, and I also need to, in this case, I'm going to have to divide everything by the a value. So here by -2. So when I do that, I divide all the terms by -2, and I add that 5 to the other side. What we're going to get is x squared plus 3 halves x plus a blank equals, I'm going to have a positive 5 divided by -2, so -5 halves plus a blank. Again, now that I've made that a value become a 1, now I can go to complete the square. So 1/2 of my b term, 1/2 of 3 halves is going to be 3/4. And I'm going to square it and add it to both sides. On the left, I now have a perfect square trinomial, so we're going to have x plus 3/4 quantity squared. On the right, I'm going to do a little math off to the side. So we have -5 halves plus 9/16. I need a common denominator, so I'm going to multiply by 8 over 8. It's going to give me -40/16 plus 9/16. Or on the right-hand side here, we're going to have -31/16. I'm going to take a square root of both sides. We're going to get x plus 3/4 equals plus or minus the square root of -31/16. All right, I can simplify the denominator here and recall that if I have the square root of a fraction a over b, this is the square root of a over square root of b. So I can simplify that denominator. The numerator, I'm going to pull an I out, but I can't simplify the square root of 31. So what we're going to have then is x plus 3/4 equals plus and minus I square roots of 31 all divided by 4. And when I subtract that 3/4, we're going to end up with x equals -3/4 plus or minus I square roots of 31 all over 4. Or I could write that as -3 plus or minus I square roots of 31 all divided by 4. Either one of these as two fractions or as one are acceptable answers here. So brings me to our quadratic equation or quadratic formula. All right. If I have any quadratic, ax squared plus bx plus c equals 0, such that a does not equal 0, then I know that x must equal the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a, where a, b, and c are the coefficients from that quadratic equation. Now there's another part of the quadratic equation that is important. It tells us some information, and it is this value here inside of my radical. Right? This value is called the discriminant. Right? The discriminant tells us how many and what type of solutions we're going to have for a particular quadratic equation. So if the discriminant is positive, we're going to have 2 real roots. If the discriminant equals 0, think about it, I'm plus or minus, I'm adding or subtracting a value of 0. So the only answer I have is -b over 2a. I have it twice, but it's just one distinct real root. It's just repeated. And if b squared minus 4ac is less than 0, then I'm going to have a square root of a negative value. Therefore, I'm going to have 2 conjugate or complex values that also have to be complex conjugates. Okay. So the discriminant, again, tells us how many and what type, whether they're real or imaginary roots to a particular roots or solutions to a particular equation. So if we're going to solve using a quadratic formula, again, we want to make sure it's set equal to 0 before I proceed. But here I have x squared minus 5x plus 3 equals 0. So a is 1, b is -5, and c is 3. So when I substitute in, x equals the opposite of b, so the opposite of -5 plus or minus square root of b squared minus 4 times a times c, all divided by 2a. All right, I'm going to do some simplification here. So I'm going to have positive 5 plus or minus the square root of 25 minus 12, all divided by 2, which is going to give me 5 plus or minus the square root of 13 divided by 2. Now I need to look if asked for an exact answer here. Can I simplify square root of 13? I cannot. This is my final exact answer. Okay, if we're looking for a decimal approximation, then you would have to plug in both the plus and the minus case. But assuming we're looking for an exact answer, we've got it. So let's take a look at another one here real quick. So I have x squared minus 4x plus 8 equal to 0. So a is 1, b is negative 4, and c is 8. Right? So we're going to have x equals the opposite of negative 4 plus or minus the square root of negative 4 squared minus 4 times a times c, all divided by 2 times a. So again, I'm going to simplify. So we're going to have 4 plus or minus the square root of 16 minus 32, all divided by 2. Simplify a little farther. We're going to have 4 plus or minus the square root of negative 16, all divided by 2. Right? I can take the square root of negative 16. It's going to give me 4i. So here I get 4 plus or minus 4i, all divided by 2. Now, one thing to note, if I want to reduce something in this form, all 3 of my coefficients must have the same common factor. Okay? In this case, that common factor is 2. So here I'm going to have x equals 2 plus or minus 2i. So let's use the discriminant to determine the number and type of solutions for each of the following. Again, remember the discriminant comes from the b squared minus 4ac portion. So here in the first, we're going to have negative 28 quantity squared minus 4 times a times c. All right, I'm going to use my calculator for that. So negative 28 squared is going to be 784 minus 4 times 196, which is 784. So here we're going to get 0. So what we're going to end up with is exactly one distinct solution. All right? When we look at it in terms of a graph, this would factor to x minus 14 quantity squared. So this is going to end up being a quadratic that shifts 14 units to the right, has one solution that occurs 2 times, right? And that's actually going to be something important for us later on, because it's going to tell us what's happening at that particular intercept, the number of times a particular solution occurs. Okay. In the second example here, b squared minus 4ac, so we're going to have 5 squared minus 4 times negative 3 times negative 7. So we're going to have 25, let's see, minus 84. All right, so we're going to get a value here that is less than 0. Okay, to be totally honest, it doesn't even matter what the value is. All we need to know at this point, it's negative, right? Which tells me I'm going to have 2 complex solutions, right? Here I had 1 real solution for that first example. So let's take a look at a couple of basic quadratic applications. So typically one of 2 things is going to happen. We could have something where we get an equation set up and then we either want to find x given y or find y given x. Or the other thing with quadratics that we're commonly asked to do is to maximize or minimize a particular equation, whether it's maximizing revenue, minimizing costs, something like that. All right. We can also look at heights of objects is another physics application. So that's what we're going to look at here. So let's suppose the height of an object is given by an equation at any time t by the formula s equals negative 1/2 gt squared plus v naught t plus s naught, right? Where s naught is the original height of the item, v naught is the initial vertical velocity of the item, G is the downward acceleration due to gravity, and an S would be the height at any time t. Okay, and the gravity, depending on, and it's important whether we're dealing with feet or meters. If we're in feet, it is 32 meters per second squared, or if we're dealing with meters, it is 9.8 meters per second squared. So let's say I have a toy rocket that is shot up from a launch pad 20 meters above the ground with an initial velocity of 24 meters per second. So I've got a launch pad that's 20 meters above the ground. Right, so this here is 20 meters high. We're going to have a rocket that's going to be shot up in the air. It's going to do its thing, and it's eventually going to make its way back toward our ground. Okay, it's going to have an initial vertical velocity, v naught, of 24 meters per second. Okay, so again, from our equation, S equals negative 1/2. We're dealing with meters, so 9.8 t squared plus v naught, which is 24 t, plus s naught, which is 20 meters. Right? I want to find the time at which my rocket hits the ground. Right? So when my rocket hits the ground, think about it, my height, or s, is going to equal 0. So we're going to have 0 equals, and if I simplify, we're going to have negative 4.9 t squared plus 24t plus 20. Now at this stage, do I really want to go through and try and, one, it's probably not going to be nice to factor. I probably don't want to try and complete the square. So my best bet here is going to be go straight to the quadratic formula. So when I do that, we're going to have t equals the opposite of b, so negative 24 plus or minus the square root of negative 4.9 squared minus 4 times a, negative 4.9 times c, all divided by 2 times negative 4.9. So I'm going to punch this into my graphing calculator using the quadratic program that I have in here. So we're going to have 4.9, 24, and 20. So I'm going to get solutions. T equals negative 0.726 for around to 3 decimal places, or T equals 5.624. Now, one of these two solutions makes sense, one doesn't. I can't have a rocket hit the ground negative 0.72 seconds before I launch it. Think about it. If I continued this parabola back in the other direction, it would have a non-existent intercept with the ground if it continued on that path back down toward the ground in the other direction, if you will. Okay? It doesn't make sense. It can't hit the ground before it was actually launched. Okay? So we have to think also about the context and whether our equations actually make sense per the context of the situation, and whether or not they're feasible with some of these problems as well. So let's say I have a geometric application here. So I have a rectangle with an area of 31.5 square meters, and the length is more than twice the width. I want to find the dimensions of my rectangle. All right, so I'm going to draw a generic rectangle here. Okay, so the length is more than twice the width. So let's call the width x. That leaves my length to be 2x plus 2, right? 2 more than twice the width. Okay, my area is 31.5 meters. Area of a rectangle is length times width. So let's substitute in. So here I'm going to have 31.5 equals x times 2x plus 2. And when I distribute, I'm going to have 31.5 equals 2x squared plus 2x, or 0 equals 2x squared plus 2x minus 31.5. All right, again here, I'm going to use quadratic formula, so x equals the opposite of 2 plus or minus square root of 2 squared minus 4 times A times C, all divided by 2A. And again, I'm going to use the quadratic formula, program in my graphing calculator just to simplify a few things for the video. So we're going to have 2, 2, and negative 31.5. So again, here I'm going to get solutions of x equals 3.5 or x equals negative 4.5. Again, I can't actually have a dimension that is going to be negative. It doesn't make sense for the context of the problem. So this negative dimension has to go away. Now I would ask, have we actually answered the question? Well, partly, but not entirely, because we're asked to find the dimensions of the rectangle. Well, I've got one, I have the width. So now what I need to do is I need to take this value for x and I need to plug it back in, and I need to find my length. So to find my length, we're going to have 2 times 3.5 plus 2. 2 times 3.5 is going to give me 7, and plus 2 is going to give me 9. So here I'm going to have dimensions of 3.5 and meters by 9 meters. Okay, so again, always make sure that you're going back and answering the question that you actually were asked to find. Let's do, tell you what, let's save this one. Let's do this in class together. I think this is a good one for us to go through as a group. But take a look at it, see if you can figure it out if you want, and then we will do this one together in class.